Hey guys, today we're going to be talking about angle relationships in circles. So there's four kinds of relationships, and the first one is going to be the chord-chord angle. So let's get a definition. Chord-chord angle is an angle formed by two chords intersecting inside of the circle. Here we have an example. This is a circle, and the red line is one chord and the green line is another chord, which both intersect right in the center and form a chord-chord angle. Actually, they form four chord-chord angles on all four sides. Okay, let's have a second one. The second one is the tangent-tangent angle. So the definition for the tangent-tangent angle would be an angle formed by two tangents intersecting outside of the circle. The diagram for that would look something like this, where there's the green line representing one of the tangents and the red line representing another one of the tangents. Okay, let's bring in another example. Let's move these up a little bit. And now we have the secant angle. And the definition for that would be an angle formed by two secants intersecting outside of the circle. And for this one, the diagram looks similar to the last one, but in this case, it's two secants. The red line and the green line would be secants, and the angle formed would be right here. And for the tangent-tangent one, the angle formed would be right here. And for our last angle relationship would be the chord-chord angle. The secant-tangent angle. We already discussed the chord-chord angle. And the definition for this one would be an angle formed by one secant and one tangent intersecting outside of the circle. So, for the diagram, it would look something like this, where there's the red line representing the secant and the green line representing the tangent. You can see for the secant, the endpoints on the circle would be this line and this line. And for the tangent, there's only one endpoint right here, right where it hits the circle. Okay, so now that we have that done, let's introduce a theorem. So this theorem is going to be discussing the relationships of the angles. Okay, here it is. The measure of an angle formed by two secants, two tangents, or a secant and an angle, and a secant and a tangent, drawn from a point in the exterior of a circle, is equal to half the difference of the measures of the intercepted arcs. Now that sounds like a mouthful, but before we show some examples, it's important to notice that for the three examples that we had, here let's bring in the diagrams real quickly. For these four that we had, these three, the secant, tangent, and secant-tangent angles formed are on the outside of the circle. All of them are on the outside of the circle. But the chord-chord angle is the only one where the angle formed is on the inside of the circle. And it's also important to know that all three of these different kinds of angles that are formed have their own relationships, their own arc to angle relationships. And that's what we're going to be discussing now. Okay, so first let's bring in the two secants example. So in this case, this would be the diagram, where x would be right here on the outside, and both of these are secants, and the arcs highlighted are this arc and this arc. And let's show the formula. This is the equation of how to find the measure of the angle. So measure of angle x, which would be right here, is equal to 1/2 of the difference of the two intercepted arcs. So the first intercepted arc would be AB. It would be AB minus arc CD. And if you subtract both of those and take half of that, then that would be how you would find the value, the measure of x. Okay, so that was the first one. We can move this now. And now we can talk about the two tangents example. So this is the two tangents example, and here is the diagram. So as you can see again, x would be on the outside. This and this would be the two tangents, and we have three endpoints of the circle, H, J, and K. And the highlighted arcs would be arc HJ and arc HKJ. And this would be the equation to find the measure of angle x. The measure of angle x is equal to 1/2 of the measure of arc HKJ minus the measure of arc HJ. And we can use that when we have two tangents. And for the last one, it would be the one tangent and one secant example. So in this case, this would be the diagram where we have the measure of angle x on the outside, and we have this line representing the tangent and this line representing the secant. And here we have to find the measure of angle x, it would be 1/2 of the measure of arc EG minus 1/2 of the measure of arc EF. So now to finish up, let's have two problem examples to solve for the measure of angle x. So both of these problems one of the problems uses the two tangents method, and the other one uses the one tangent and one secant method. So first, this is the diagram. So here we have a secant and tangent angle, and the measure of the angle is 56 right here. And we know that 180 degrees is from this endpoint until this endpoint, and we're asked to find the measure of angle x. So in order to solve this, we can use the formula above, and what we would have to do is plug in 56 as the measure of angle x. So 56 is equal to 1/2 of 180 degrees, which is right here. That's one of the arcs that we're given. 180 degrees minus y. And I'll show you where we get the y from. The y is right here. That's the other angle. That's the other arc that we are given. And we can write in y to make solving for the equation a little bit easier. So now that we have that, it's time to solve. So we can multiply the 1/2 and by keep, change, and flip, and multiply it by the 56 to get 112. So 112 is equal to 180 minus y. Okay? So now, in order to get y, we subtract the 180, and y is equal to 68. Okay? And now we're not done yet. That only gives us the measure of this part of the arc, which is y. And in order to find this part of the arc, which is x, what we would have to do is plug this in by subtracting from the measure of the entire circle. So we'll take 360, which is the measure of the entire circle, minus 180, which is this arc that we know, and we can add that to x. We can subtract that from 68 as well, because 68 would be what we have as the measure of angle y. And this would give us the value of x. Okay? So now, if we do the calculation here, x is equal to 112 degrees. Like that. And now for our last problem, we're going to have a one tangent and one secant method. And this is the problem, as you can see right here, where the measure of this gray arc is x, and we're given that the angle is 42 degrees, and these are the two tangents. So in order to solve this, we can plug in the 42 as what we know the angle is, the measure of angle x, and we make that equal to 1/2 multiplied by x, this x, minus, in parentheses, this, and we can call that 360 minus x, because we know that the measure of a circle is 360 degrees, so if this is x, this has to be 360 minus x. So 360 minus x. Okay, and now we can multiply by 2 on the other side to get 84, which is equal to negative 360 plus 2x. That's what this would be simplified down to when you subtract the x from the 360 and the x from the 360 minus x and subtract x from all of that, okay? And now when we subtract the 84 on this side and then divide by 2, we can isolate the x, and we know that x is equal to 222 degrees. And that's how you would solve it. Okay, thanks guys for listening. Today we learned about angle relationships in circles. Make sure to like, follow, and subscribe, and stay tuned for the next video. Bye guys.